Hello, my students. Today I'm going to be doing lesson 5.8, which is complex number operations. And I'm also going to be going over the assignment 5.8, which looks something like this. So I'm going to do it in that order. First, I'm going to go over the notes, and then I'm going to do the assignment. So what we got are complex number operations, meaning we understand what a complex number is. It looks something like I, like that. And that I, we remember that it's supposed to represent square root of -1. So since we know that, that means we can take advantage of that definition and use it as the basis for how to do operations with these types of numbers. So whenever we have i's, we're basically just going to treat it like a variable. So if you see in the success criteria, we can FOIL, we can combine like terms, we can do conjugates, which I'm not sure if we've mentioned explicitly with variables, but we could do that. We could multiply two complex conjugates, which we haven't talked about with variables, but we for sure have done. But anyways, let's just see how this looks like. So it says multiplying complex numbers. We got one complex number here, and then another one right here. 4 minus 2i, and then -3 plus 7i. Real quick as a refresher, we can say that complex number z is equal to a plus bi, where a and b are any row numbers. So if we define it like that, this is a z, by the way, right? Kind of weird sometimes, but yes, it's a z. So it's saying step 1, we want to distribute both terms. So distributing sounds a lot like foiling. So foiling, hopefully you guys are getting the hang of it by now. So you just multiply each number with the inner layer and then the outer layer. So 4 times, here, let me erase the arrow so I show each one individually. So 4 times -3, that is -12. And 4 times 7i is a 28i. And -2i times -3 is a positive 6i. And -2i times 7i is -14i squared. So this is probably a good time to add that whenever we had I squared, we were able to define that as -1. So anytime we see an I squared, we also want to replace that as a -1. And that's exactly what step 2 says. So we did step 1. Step 1 is distribute, FOIL, check. Step 2, we want to see any I squares and replace it with a -1. So I'm going to do this plus 28i plus 6i minus 14 times -1. So now here, I'm just going to combine steps 3 and 4 so that we can do this type of operation quickly because it really is just foiling, except with that added step of changing any I squareds to -1. So at this point, we see we got two like terms here, and we're going to have two like terms here at some point. So that's going to be, let's see, it's going to be -12 plus 14i. And then we're going to have the plus 34i. The reason we got a positive 14 is because the -14 times the -1, which came from the I squared, equal positive 14, and that's going to be subtracted by the -12. Meaning our answer is 2 plus 34i. Looks pretty similar to how we defined a complex number up here. It's pretty much just foiling with that added step of changing any I squareds to -1. So let's see how these look. Hopefully they're not too bad. So it says simplify the following complex operations. All we got to do is get... Okay, so for these first three, they look like they're just being added. So all we got to do, added and subtracted. So all we got to do is distribute that negative value. And then from here, we combine like terms. So I'm just going to do this for this first example. Specifically highlight what is being added. So 2 minus 3 is -1. And then 7i minus 4i is a positive 3i. That is your answer. Next thing we got this one. We got 8 plus 3i plus 2 minus 6i. So whenever we have a negative in the front, we just distribute that negative and it flips the sign. So if it was negative, now it's positive. If it was positive, now it's negative. Adding everything, we have 10 minus 3i. So this is just combining like terms, like how you guys have been doing for quite a while now, since Algebra 1. And finally we have negative 9 plus 9i for this one. Alright, pretty good. Now let's see how that looks like when we start foiling. So again, I'm only going to do it for the first one where I explicitly show what I'm multiplying. So this 2 times 3, that means we got 6. Then we got 2 times 4i. Now we have a total of 8i. Then we have 7i times 3. That is 21i. And then finally we have 7i times 4i. So that's 28i, but there's 2i, so we do I squared. Next step, we combine like terms. So we combine those i's together right here. The only difference is that 28i squared now turns into 28 negative 1. Now here I'm going to do one step. We got 28 times negative 1. That's negative 28. And then negative 28 plus 6 right here in the front is going to be negative 22. So feel free to write each step out in the work and the homework, but unfortunately I did not give you guys enough space for these problems. But no matter, we'll just do it here. We're going to FOIL here. 8 times negative 2 is negative 16. 8 times 6i is 48i. 3i times negative 2 is negative 6i. And then finally we got 18i squared. So we got negative 16 plus the 42i. I'm just going to write minus 18. Because that 18i squared right here just flips into a negative. Now combining like terms once again, we're going to have negative 34 plus 42i squared. Last example. We're going to do this FOILing stuff again. So negative 4 times 5 is negative 20. Negative 4 times negative 3i is a positive 12i. Negative times a negative. 6i times 5 is 30i. And then 6i times negative 3i. So that is negative 18i squared. So now we just combine like terms once again. Hopefully this gets repetitive and even boring. Because if it's boring, then maybe that means you know how to do it. 18. So it changes from negative to positive. Once again, we combine like terms, giving us negative 2 plus 42i. So definition, we got this next part, which is called complex conjugates. And the definition of that is each of two complex numbers having their real parts identical. Real parts being this a part right here. And their imaginary parts of equal magnitude but opposite sign. So whenever we say sign, we literally just mean that sign in the middle is flipped. So it's pretty intuitive to find definitions for this. So on the right, in the table on the right, we got a complex number 2 plus 3i. Its conjugate, its complex conjugate is 2 minus 3i. So the only thing that's really changed is the sign in the middle. We could also go backwards. If we know the conjugate is negative 4 minus 7i, we know that we have a negative 4 plus 7i. So they're conjugates of each other. You don't have, one isn't the number and the other isn't the conjugate. They're both conjugates. They're pairs. It's kind of a way to say conjugates is a pair. And now we're going to see what happens when we multiply two conjugates together. We're going to multiply it the same way we've been doing it. We're going to FOIL like this. And we're going to see exactly what happens. So 2 times 2 is 4. And 2 times negative 3i is minus 6i. 3i times 2 is a positive 6i. Finally, we got 9 minus 9i squared. Combining like terms, we see that these two I terms in the middle cancel out, giving us 4 plus 9, which is 13, which is kind of interesting. We multiplied two conjugates and we got a real number. That might be interesting. Let's see if this is a pattern. So negative 4 times this negative 4 in the second example, it's going to be positive 16. Negative 4 times 7i, negative 28i. And negative 7 times negative 4 is a positive 28i, because negative times a negative. And then finally, negative 7i times 7i, that is a negative 49i squared. And look at that. The middle term right there seems to cancel out. Minus 28i plus 28i, they cancel each other out. So all we got is 16 plus 49, which is 65. So this is very interesting because it seems every single time we multiply conjugates, the imaginary term cancels out. And that's what I'm going to write here. And this realization is very important because it's going to help us understand how we can simplify division by complex numbers. If we want complex numbers to be simplified, if we want a real number, then maybe we need to multiply by the conjugate. And that's exactly what dividing by complex numbers looks like. So step 1 is to multiply the numerator and the denominator by the conjugate of the denominator. So the reason being, we see this denominator right here, and we want to multiply it by something that's going to cancel the imaginary term out. Point being is going to be 2 plus 5i. But whatever we do to the bottom, we also have to do to the top. So it's going to look something like this. And the process is we're going to multiply everything. We're going to FOIL everything out. Hopefully, we're going to see some things kind of simplify. We're going to do these bottom 3 examples because I did not leave enough space to do a top right one. So, okay, so step 1, multiply numerator and denominator by the conjugate. So let me zoom in a little bit. Conjugate refers to the term that is equal but opposite. So we just flip the sign. And we have to do that to both the top and the bottom. So when we do that, we end up with something like this. I'm just going to rewrite it to be very clear about what we are multiplying. And then this is going to be 5. So we know that that middle term cancels out, but it's okay. We'll still write it all. 5 plus 4i. Same thing. It's written exactly the same. So now that we got this, we're just going to FOIL everything out. So the top thing, we go like something like this, which is 15, and then a positive 12i, and then a 2i times 5, which is 10i, and then a 2i times 4i, which is 8i squared. Now that we're dividing, we're going to divide by that thing at the bottom, which is going to be this thing distributed, which we got to keep in mind. That middle term cancels out. So it's going to be 5 times 5. And we're going to do the 5 times the 4i. So that's 20i. And then we're going to have the minus 20i. I forgot to write the I in the first one. But it doesn't matter. Just look at that. They cancel out. Plus 20i, minus 20i. Finally, the last term at the end, I squared. So if you don't see exactly what happened, we FOILed like this. From here, we want to simplify as much as possible. 15 plus 22i, which is the numerator. I'm just combining like terms. These two, this is 22i. That's just stayed as 15 right here. It's going to be minus 8 because the I squared turns into negative. Then here we got 25 plus 16 because I squared turned into positive. Finally, we get something that looks like 7 plus 22i over then 25 plus 16. That is going to be 41. So the proper way to write this would be to divide each thing by that denominator. We separate the two parts. So this should be our answer. So it's 3 big steps. We multiply by the conjugate, we FOIL appropriately, and then we combine all the like terms. Those 3 steps. Let's look at this next one real quick. So we're going to multiply by the conjugate of the denominator again. Let me just do this like this so we understand what we're multiplying. So we got 2 minus 5i, and 2 minus 5i, top and the bottom. Now when we're writing this, we're just going to FOIL the same way that we've been doing. So 6 times the 2 is 12. 6 times the negative 5i is minus 30i. Then we got a 10i. Then a minus 25i squared. Then from here we have a 4 plus, actually not plus, minus 10i plus 10i minus 25i squared. Familiar with the fact that they cancel out already. So then we have 12 minus 20i. We combine these two things. Plus 25. All of that divided by 4 plus 25. So just keep in mind, I'm just looking at whenever we have an I squared and changing the sign of that term. So before it was minus 25i squared, now it's positive 25i squared. And I'm in the process, I'm just combining any like terms. So from here, we just combine more things. We got a 37 minus 20i divided by 29, giving us an answer of 37 minus 29. All of that minus 20 divided by 29 times I. Looks like a big crazy answer, but it really isn't too bad if you just follow the same foiling steps that we do with variables. And now we'll move on to the last one. So we're going to do 9 plus, not plus actually, it's the conjugate, meaning minus 2i. And then we got 9 minus another 2i. And if we FOIL everything correctly, we got negative 72 plus 16i. And then we got a plus 27i minus 6i squared. All of that is divided by, you can just do a shortcut here. This looks a lot like a squared minus b squared. And we know that that is equal to a plus b, a minus b. So this is similar to the difference of squares, but just kind of in backwards. We see conjugates like that, so we know that it has to be a difference of squares. And by extension, we know we got 81 minus, then it's going to be 4i squared. If you don't see this pattern, it's okay. Just take your time foiling every single step, foiling with every single step and every layer. But know that you could do that shortcut. Just take out the middle terms and square the first and the last. And now that we have this, we can just take our time, combine all the like terms. And then 81 plus 4. Oh, I forgot to put an I right there. And we got negative 72 plus 6. That is going to be negative 66 plus the 43i. It's a bunch of numbers and letters, but hopefully the arithmetic is the easy part. The part that you guys understand. Plus 43i divided by 85. And that should be your answer for this last question. So maybe this division of complex numbers is a bit more complicated, but hopefully you understand what we're trying to do. We get the foiling of conjugates, and that cancels out the imaginary term. That's what we had said here. That is the most important part for division. The imaginary term cancels out. And we know how to FOIL, which is what we did up here, which is what we've been doing with normal variables. And we're going to see how we can get started on the homework real quick. I think I'll just do like 2 problems super quick to get you guys started. So I'll do number 4, I think. This is the problem. It's only 6 questions. I don't think it should take you guys super long. But we got this. We got 4 times 4, which is 20. 4 times -3, which is minus 12i. 7i times 5, which is positive 35i. And then 7i times -3i, which is minus 21i squared. Here we combine things. We could combine these 2 things right here. So we got 23, I believe. And we know that this I squared turns it positive. So super easy, we got our answer. Finally, we just combine these last 2 things. 41 plus 23i. Very fast. 41 plus 23i. And I'll do number 6 real quick. Just so you guys don't have so much work to do by yourself, especially because I'm not there. So what we have to do is multiply by the conjugate again. I just like reiterating things so they get burned into your brain. So 2 minus 3i, the top and the bottom. Whatever we do to the bottom, we have to do to the top. And that's going to equal, if we distribute this stuff correctly, if we FOIL normally, we're going to get 10 minus 15i minus 8i plus 12i squared. It's the same FOILing steps as before. Here, I'm not going to do the shortcut this time, just so that I could be redundant with the steps, so you guys understand it clearly. We got 4 minus 6i plus 6i minus 9i squared. This is the part where we combine anything that we can. So at the top, I see these 2 things, and I combine them. 10 minus 23i, and then we have a minus 12. Just remember that I squared makes it minus. I also see that these 2 things cancel out, so we just end up with 4 plus 9. Is that the I squared again? We just keep evaluating. We end up with minus 2 minus 23i. All of that divided by 13. The proper way to write it would be the real part disconnected from the imaginary part. Like that. So that's pretty much it. It's just basic operations with complex numbers. And it can seem pretty confusing, especially with the nomenclature imaginary. Like, what are we doing this for? It's just imaginary, it's not real. But I promise you that this is real in the world that we live in, and in the world of mathematics, which is the fabric of our universe. And that's how I like to connect it from what we're learning right now to how it applies to your real life. So hopefully this made sense. You can always message me if you have any questions. But if not, I'll see you guys